Bob's business has an expense rate described by the function E of t equals 10 natural log of t plus 1 measured in dollars per month. His business has an income rate described by the function I of t equals 4t dollars per month. Is the amount of money in the business bank account increasing or decreasing when t equals 9 months? Give a reason for your answer. So there's two different rates acting here. That makes a difference, of course. Give you all a chance to think about how this would work. And I would say this is, for sure, calculator active. And for the benefit of everyone, especially Jaden and Jeff, what mode do we live in here in AP Calc? No, it's not that. They're feeding you full of bad information. It's radians. Jeff, maybe you shouldn't listen to them. Did they tell him the wrong one?
He said music mode.
Did you
talk about music modes and then she
Oh,
said
I'm
Depeche
sorry.
Mode.
Oh, Depeche Mode.
Depeche Mode.
Love it.
That's the mode. Don't listen.
Depeche is the mode. Oh, man. Classic early to mid 90s, right? Is that about right?
Something like that. I think
I
so.
love Depeche Mode.
Electronica kind of stuff, yeah.
I also like soft cell a lot. I'm a big disco fan.
I like to know these things. That's cool, Liz. No, Depeche Mode was more like late 80s, early 90s when they really got big. I was just trying to think. I was thinking about my own high school, college time frame there. Yeah, it was like late 80s, early 90s they got big. Yeah. It's about time for them to come back around and get popular again, right? It's been 30 years. So Jaden, what do you think about this one?
Can I tell you what I think? I think that they should shut down their business since they're only making $15 a month.
Maybe you should put this, maybe the units should be thousands of dollars per month?
Probably.
Okay, fair enough. Okay, let's talk about how this should work. This is a classic case of two rates that are working against each other, right? So the expense rate is money that's going out of the business, right? They're having to spend it. But the income rate is money coming into the business. And so these two rates are kind of working against each other. So you could call this like a competing rates problem or maybe a net rate question. So I would say that the overall rate of change of money in the bank account would be I of t minus E of t. And why would it need to be in that order? Because the order matters. Why that order? Yeah, it's rate in minus rate out, right? So like income would be a positive influence on the bank account. Expense would be a negative influence on the bank account. So I of t minus E of t, we are interested in what's going on when t equals 9. So I would say I of 9 minus E of 9. This is going to give me the overall net rate when t equals 9 months. So calculator time, what'd you guys get if you did that?
12.974.
12.974. Jack got like 15 point something, right?
I'm just bad at math.
Yeah, I think you're
Do you guys agree with the 12.974 number? Okay.
Oh, I did minus one instead of plus one in the parentheses.
Okay.
There we go.
So of course this is, unfortunately for this business, this is measured in dollars per month. So as Jack accurately pointed out, they are turning a profit, albeit a small one, since the units are dollars per month. Slightly under $13 per month, whatever. If this were a lemonade stand for like a 5-year-old, they'd be doing okay, But if it were a bigger business, not so. Here is. These guys should go on Shark Tank and get some advice, right? Something like that. Anyway, 12.974 is neat and everything, but what's the most important thing about that number?
It's greater than 0.
It's positive, yeah. It's a positive number, And so because the net rate is positive, we can use the little therefore triangle and say, therefore, the amount of money is increasing when t equals 9 months. So if the rate of change is positive, that means the amount is increasing. If the rate of change is negative, that means the amount of whatever it is decreasing. So to specifically address the question, that's the most important thing. Okay. Say again?
We don't know how many hours he's working this month.
Maybe he's only working like 3 minutes a month.
Or 3 minutes.
And that's a lot better effort, right? Yeah, he's making some pretty good money for only 3 minutes. All right. Here is another nice example to go along with this. Notice I'm trying to throw all kinds of different things at you. I'm trying to think of all the different types of forms of things you might see, combinations of things. Here's another nice example right here. It says, for the time interval 0 to 10 minutes, the rate of people entering the Pepsi Center is f of t. The number of people who have left the Pepsi Center at time t is given by that graph below. Is the number of people in the Pepsi Center increasing, decreasing, or neither when t equals 8? So on some level, this adds a layer of complexity to number 2. So I want you guys to think about example 3 here. Think about how this graph should be interacting with f of t to help you reach a conclusion. You might look at this and pretty quickly recognize, oh, it's one of those net rate, competing rate scenarios where you have two rates kind of working against each other. And you might be tempted to write this, f of 8 minus g of 8. And listen, I hope you picked up on this, but this would be a mistake. Here's the reason why this would be a mistake. F of 8 is most definitely a rate, and that is something that we want to think about. But g of 8 is not a rate. G of 8 is an amount. And so this is apples and oranges, oil and water. These two don't mix. You can't take a rate minus an amount and get anything usable. It needs to be an amount minus an amount or a rate minus a rate or something like that. And so we do want to analyze the rates here to determine if the number of people is increasing or decreasing or neither. So I want to keep that f of 8. What do I need to do with the graph? What do I need to do with the g function instead of what I just did? Derivative. Yeah, I need to figure out the derivative, except the only problem is I've got a graph, and it's going to be easiest just to deal with the graph. So if I do want to find the derivative of 8, or derivative of g at 8, what do I need to look at on the graph? The slope. That's right. I don't want to know the value of the graph when t equals 8. I want to know the slope of the graph. Thankfully, it's a line, so it's not too hard to figure out. It looks like the slope is 1, doesn't it? Am I off on my scaling? I say, oh, you know what? It is, so... No, it's scaled the same. Yeah, so it's up 1 over 1, up 1 over 1. Okay, that's all right. So this is also a rate. I know that f of 8 is going to be natural log of 9. And g prime of 8 is 1. So it'd be natural log of 9 minus 1. And honestly, you don't even really have to put this in the calculator. You could if you wanted to. We can say for sure that that's positive. So I think we could say, therefore, the number of people is increasing in the Pepsi Center. So I actually wrote this question based on an old AP question. It was something else entirely, but it was like the combination of a function, we were given the rule, the other function we were given like an amount instead of a rate, and we got a graph for it. And so you just want to be ready for these kind of odd combinations. You could even throw a table in there at some point, table of values, and who knows. So they do throw lots of different combinations at you. Just make sure you understand what you're doing. How are we feeling? Jaden and Jeff, I won't single you out, necessarily make you uncomfortable, but it's the elephant in the room. I don't want to ignore it. You guys doing okay? Am I going at an okay speed? Yeah. Okay, awesome. All right, well then let's take a look at what comes next. So this is the next part of the little video here. And this is talking about local extrema. I'm going to just kind of cruise through this a little bit. It's talking about the first derivative test and how all that works. And we're going to get to a few examples here. I'm sorry if this one makes you cry. I don't know. It says rabbits are reproducing at a rate of R of t, but they are dying at a rate of D of t. But Josiah's out there with his gun.
Find the day. Find the day on which all of the rabbits are dead.
With what?
Is it because of the wildfires?
What'd you do?
It must be because of the wildfires. His work.
Okay.
Her bunny had gotten into some poison, and then it started painting like blue and green, and so Josiah put the poor guy out of his misery.
Is this true? That was
Oh my god, you smashed.
wow. I had no idea our class was going to take this turn today. Poor Josiah. He's like, why did you have to say that? So Josiah, let's call that merciful. It wasn't necessarily nice, but it was merciful, right?
It was the right thing.
It was the right thing.
Murder is the right thing to do.
I just wanted to hold.
I think it's the wildfire killing him off.
According to everybody else, it's Josiah that's killing him.
Josiah!
Yes.
Josiah,
Oh, brutal. So sad.
I'm like, maybe it's a crime scene of your own.
Man, oh man. All right, let's refocus. Oh my gosh. Hey, let's refocus. Okay, so we got these bunnies. They're being born and they are dying for whatever reason. And it says, at what time t on this interval 0 to 50 is the number of rabbits at a relative minimum? So this is a pretty nice segue from what we've been doing. We've done 2 examples in a row where there's like a rate that's causing something to increase, and there's a different rate that is causing that same thing to decrease. This is the same scenario, right? But notice this does not ask the same question. It doesn't say, is the number of bunnies increasing or is the number of bunnies decreasing? It wants to know, when do they reach a relatively high population, right? A relative maximum, or excuse me, relative minimum. So where do they reach a relatively low population? So we got these 2 rates acting against each other, and they are rates. So would you guys do R of t minus D of t, or would you do D of t minus R of t? Yeah, you could mix the order up, I agree. But I'm going to go R of t minus D of t. But instead of me plugging in some number and just taking guesses at this, I want to be very focused and have some candidates for where I might have a relative minimum. At what candidates do relative minimums happen? Critical points, but not endpoints though, right? Because endpoints would be if we're considering absolute extrema, and this uses a very specific word, relative extrema. So for relative extrema, you only have to worry about critical points, critical numbers, and critical numbers are places where? F prime equals 0, the derivative equals 0. Here's where it's really tempting to make a mistake. If I want to set the derivative equal to 0, what is R of t minus D of t? Is that the derivative, or do I need to differentiate that? Isn't that already the derivative? It is. So it's really tempting. Some people think, hey, I'm in a calculus class, I better be finding derivatives. You don't know the truth? You already found it. It's right there. R of t minus D of t. You don't have to do any extra work to find it, but you do need to identify it as being the rate of change of the number of rabbits. So I'm going to set this equal to 0. I do not think that D and E comes into play here because we have basically a couple of exponentials, and I don't think there's any places where exponentials don't exist. So I think we can safely ignore that part. This is clearly a calculator active question. I would not ask you to set R of t minus D of t equal to 0 and solve that without a calculator. I'm sure it's doable, but it would take way too long. So let's not do that.
It'd be fun though.
Okay, we could. Yeah, actually, I'm going to teach you guys a method pretty soon called Newton's method, where you could do it without a calculator, and in a relatively short amount of time, and you could estimate it down to whatever far digit you want.
Interesting.
But the calculator's still better, I think.
You should do one test, like, or just one of those.
What?
Like just big calculator active problems, but you make it no calculator.
Well, Jake, if you want to come during like an afternoon or something, I'll just give you one of those.
Okay.
If you
I will.
want that, just
Math club.
Yeah, I was going to say, I don't know if everybody else wants that.
Jake can do it for.
All right, what did you guys get for t? Were there 1 critical number on this interval, or 2 or 3? Just one. Okay, so t equals what?
22.026.
22.02...
23.
23.
23.026.
23.026. We agree with that?
Yep.
Is that good? Well, we're not there yet. Let's think about this. What have we actually found? What is that thing? It's a critical point. Notice it did say justify your answer. So the critical point is really the only candidate we have, but we need to confirm essentially that this really is where the number of rabbits has a relatively low population. So this is where we get into the first derivative test, right? So what I'm going to say is this. Here's my justification. I'm going to say R of t minus d of t equals 0 at t equals 23.026. And what is the pattern of sign change? Is it negative to positive? You can see that from the graph probably. And we would say R of t minus d of t changes from negative to positive when t is equal to 23.026. Therefore, the number of rabbits is minimized or has a relative minimum then, or we could say when t equals 23.026 again. So the elements, the good elements of a justification, you want to for sure confirm that you have a critical point. So you want to see that the rate of change of whatever it is you're finding is 0 at this particular critical point. And then you've got to show that the rate changes sign from negative to positive for a minimum or from positive to negative for a relative max. Question, Johnny?
I was just clarifying because I don't quite remember this from last year.
Yep.
Can you just create a new function? Like I made a b of t, and then so like b prime of t would be.
Absolutely. Yeah, so I think Johnny brings up a good point. So if you, what was your letter?
B of t.
B. Yeah, so if you said b prime of t equals that, is that what you put?
Yeah.
Okay. So then, and then if you just replaced all of these with b prime, that's totally fine. You can make up your own function and call it whatever you want. As long as you define what it is, totally fine. Definitely totally fine. Liz?
How come you don't have to worry about the negative exponent on t?
Because, so the e to the negative 0.5t. So if we just look at that part, because you're talking about the,
E can never be 0. Never mind.
well, yeah, that's the point. Like there's no t value you could plug in there that would make that whole thing equal 0. If t was approaching negative infinity, then that denominator would approach 0, but even then it's still not even a real number. So, yeah, good question. Anybody else? Any questions at all? Okay. So, can you guys confirm for Jeff and Jaden that we're going through this at like rapid pace? Like,
Hey.
good one. I like it. So if you guys are keeping up, good job. Take a look at example number 2. Example number 2 says, let f be a function defined on negative 5 to 5. And like the very first example we looked at, this says the graph of f prime is shown below. So you got a graph of f prime. It wants to know about the relative maximum or perhaps an inflection point on f. And it also wants you to justify your answer. So 2 questions here using that graph. Let you take a few minutes and give it a shot. Even if you are a veteran and you had A, B, and you did really well and you feel confident, you still want to practice writing your justifications, right? Hey, I think this is an inflection point. Practice writing it out. If you don't write it out, if you just do it in your head, it's going to sound good up there, but sometimes when you try to go from head to paper, it gets all jumbled up and you're like, whoa, that's not what I meant, and I'm confused now. So practice writing it, even if you think you're doing awesome, and you might be. Just practice.
Realize
We're looking for where f has a relative maximum. That is going to happen wherever f prime is equal to 0 and changes from positive to negative. I'm just putting little notes up here to myself. So, as I look at the graph, I'm looking for where f prime is 0, and that happens in several places on the open interval. It happens here, and here, and here. So 3 places where f prime is 0. Right here at x equals -3, what is the sign change pattern within f prime?
Positive to negative.
And that goes with maximum, doesn't it? So I'm going to say f has a relative max at x equals -3. And are there any other points?
4.
At 4 as well. This right here would be a relative minimum, so I don't want that. But over there at x equals 4, I do have the same sign change pattern. So I'm going to say and x equals 4 because f prime changes from positive to negative. You know what? I didn't put this yet. I want to make sure I write this down. I'm going to say f prime equals 0 and changes from positive to negative at those points. Okay, so look at the justification that you wrote down. Compare it to mine. There could be some slight variations and differences in wording. But listen, do you have the key elements? I'll highlight them for you. Have you mentioned that f prime equals 0 at those points? You need to mention that. And have you mentioned that f prime changes from positive to negative at those points? No matter what order you put it in, if you have those 2 elements, you have a good justification. Does that make sense? Okay. All right. And then the other part was asking for where f has an inflection point. So let me ask you guys, how many inflection points do you think f has? 2? 3? I will agree with that. I will agree with that. So I'm going to say this. F has 3. F has 3 inflection points. And here they are. Because at x equals -4 and x equals 2, f prime changes from what to what? Increasing to decreasing. There you go. And at x equals -1, f prime changes the other way, from decreasing to increasing. So as you remember the other day, this is where it starts to get a little muddled up, right? F prime does this, that means F does that, and we're starting to add a lot of layers to this. And so we want to make sure that we're taking the time to keep these straight and practice writing our justifications and making those connections. Brandon, go.
Could you just say that for all of them, their inflection points, because F double prime changes sign?
So he said, I don't know if you guys heard his question, he said, could you just use essentially as a blanket justification because at those points F double prime changes sign? Often that will be taken for sure as a good justification. I think it's best practice to address the information that you've been given. So since you were given information about F prime, I think it's best practice to use F prime. But I can't think, at least on an AP test, I can't think of a time when they have not taken something like what you said. Yeah, go ahead, Colin.
So this is my question. Do you need to be that specific, or because what I said is
The vice versa thing?
yeah.
Yeah, so they're tightening up a little bit on the vice versa. They want to, so their philosophy there is they want to make sure that you are addressing specifically their question versus sort of like a recipe, like, oh, it's this or that. They want you to be real specific. So that being said, they did make an exception last year on one of the alternative forms, but whatever. They sometimes break their own rules. Whatever. They always have good reasons. Any other questions? These have been real good so far. Anything else? Jeff?
So why is 1 not included in the first?
Why is 1 not included as a... because... you're talking about for the relative max?
Yeah.
So at x equals 1 right here, f prime changes from negative to positive, and that is a sign change pattern for a relative minimum, and it specifically asked for a relative maximum. So if it said, like, find all the relative extrema, then we'd have to include mins and maxes, and so in that case we would have included it. But since it just wanted maximums, we'll ignore any minimums. Anybody else? Okay. We are going fast. You guys are doing a good job keeping up for sure. Okay, so here's a little artwork for you. You got this graph of G over there on the left. Sorry for the different colors. I forgot to change the color on Desmos for the blue part. Whatever. There's no hidden meaning to the fact that it's blue. So anyways, please sketch a graph of G prime based on the graph of G that's over there on the left. I can definitely tell there is been a little bit of rust that's built up over the last whatever time frame. So I want to give you guys some help here as far as how we do this. So listen up. Here's how I approach this. First thing I'm going to look for is where is G prime 0? Listen carefully. I want to give you a good system. You can use this system every single time. Where is G prime 0? I see G prime being 0 right there. And right about there, I guess, something like that. That makes sense to you guys? So that's where G has a horizontal tangent line, so it's where G prime is 0. So I'm going to say that's at like negative 3 and just slightly past 3, something like that. So I've got a couple of zeros there. It's really important that you put those zeros in there first because you know that the graph of G prime is going to have to go through those points, right? Next thing I'm going to do, I'm going to just make a mental note of any points of non-differentiability. I see one right there, and I think I see another one right there, 2 points of non-differentiability. So I'm going to just make note of that, so when I sketch this graph out, I'll realize that those need to show up in their own unique way. Beyond that, though, all I really look at is on what intervals is G prime positive and where is G prime negative. So I'm going to go from left to right here. So on this interval over here, would you guys say that G prime would be positive or negative? Negative. Definitely negative. And so on the graph of G prime, it needs to show up below the x-axis. So I'm going to just say something like that. The reason why having those zeros in there ahead of time is really important is because I know that it's got to connect with that 0. So G prime is negative there, but it's going to hit 0 right there at about negative 3. So then as far as the rest of this red interval is kind of interesting because it looks like for this part of the red interval, it looks like we still have sort of a parabola-ish looking graph. But then from here to here, it looks like maybe it switches over to a linear graph. But it looks like a pretty smooth transition to me. Does it look like a smooth transition to you? Yes. So it could still be differentiable there. I don't think we have a point of non-differentiability. The most important thing, though, is simply that that red stretch, G prime is positive or negative? Positive. So it's got to show up above the x-axis. So, if you did this, I'm probably not going to get too terribly upset, although I think probably it should go maybe something like that. I think that'd be pretty reasonable because I do.
So that would it have to be a little higher though because it's still
Oh, I don't know. I hope you don't want me to grade your test like that. Let's look, Josiah. I agree. We could do better. Looks like a slope of 2. Slope of 2. So I'm going to go with this. And almost got it. How about that? Josiah's right. It should be a little higher. He's right.
Thank you, Josiah.
Get out the protractor and be like, yeah, okay. Really important feature, though. And by the way, Josiah does bring up a good point. I don't think I'd mark you wrong if you're off by, a little bit here or there. I'm just looking for a sketch, but let's make this as good as we can. Here's a feature you got to have. You got to have an open circle right there. That's a non-negotiable because we do have a point of non-differentiability. Looks like the slope of G drops down to a -1. So I'm going to drop this down to about here. And it would be constant all the way over there to 2. Maybe something like that. And then I do think we have maybe a point of non-differentiability right there at 2. We jump up to a what looks like an almost positive slope. Maybe, I don't know, it's not very positive, maybe something like this. It is going to go to here because we have a positive G prime for just a short stretch there. And then this green interval, G prime is clearly negative, and so it's going to go down through over to there. So that's a graph of G prime. Got a couple of points of non-differentiability, 2 zeros, all the pluses and minuses there. What do you think? Does that system help? Graph your zeros, make a mental note of the non-differentiable points, and then just go G prime is positive or negative, positive or negative, positive or negative. Do your best with lines. We'll call it the Josiah rule because he was on it. He was on top of it for sure. So the last thing I want to do here is just make a little discussion in regard to velocity and speed, and then we'll do an example when I see you guys again on Monday. So here it is. This will be just a little bit of recall for most of you. This might be a little bit of learning for those that have never had a physics course or maybe forgot or whatever the case might be. So velocity, is it a vector or is it not a vector?
Vector.
Velocity is a vector, and so direction and sign, like positivity or negativity, will matter. So here's the thing, in our class, we're going to start off here kind of like AB, where all of the objects that we look at simply move in one dimension. They either go left and right all the time, they just do this back and forth, or they go up and down constantly. When we get towards the end of the first semester, we're going to let those objects that used to go left and right only, we're going to release them to move up and down at the same time as going left and right. And if you take Calc 3 ever, not only will they do this, they'll start moving towards you and away from you and left and right and spiraling all over the place. So it's 3 space. It just adds one layer of realism to it. So, speed, not a vector. Speed is always positive. And hopefully that will go well with this next statement, the fact that the speed function is the blank blank of the velocity function. Absolute value is the correct. I'm actually going to go back and correct something I said. I said speed is always positive. That's actually not true. Speed is never negative, because speed could be 0. So anyway, speed is never negative because the speed function is the absolute value of the velocity function. Here's the thing that hopefully you'll be able to remember for Monday. We'll use this for sure. Speed is increasing in one scenario. When?
Velocity and acceleration is the same sign.
There it is. Nice job, Jasmine. When velocity and acceleration have the same sign. And speed would be decreasing when? They have opposite or different signs. Yep. All right. We almost timed that perfectly. I think we just hit 3 o'clock. Yes. Thank you for your hard work. We'll finish off with this whole speed and velocity thing on Monday. And then we'll be moving into section 3.4. There is a video for 3.4, so please do check that out. Appreciate your hard work. Have a great weekend. See you on Monday.